All right, folks, we're on to the next theorem. Hopefully you just watched the video and learned about the rational root theorem. Well, now I'm going to teach you about what's called the remainder theorem. The remainder theorem. And here's what the remainder theorem says. It has to do with, well, one of the best ways to use it is with synthetic division. You know how synthetic division, when you do synthetic division, you get a number at the end, that's the remainder. Well, here's what the remainder theorem says, okay? Well, actually, it's better if I just show you what the remainder theorem says. Let's say that we have this function here, okay? And I don't know if you're aware of this, but when you have a function, if you're asked to identify, for example, what is f of 1, that simply means what is the function f of x when you plug in the number 1. So to identify f of 1, we would put a 1 where this x is, we'd put a 1 where this x is, and then we would multiply and add and subtract. Okay, so if we put a 1 here, 1 to the third power is 1, so we'd have 2 times 1, plus 5 times 1 squared is also 1, minus 7. And so then 2 times 1 is 2, plus 5 times 1 is 5, minus 7. And 2 times 5 is, or 2 plus 5 is 7, minus 7 is 0. Okay, so we know that if we were to plug a 1 into this, the answer would be 0, and that's going to become important later. Okay? But sometimes when you plug numbers in, it's not as easy to plug in as the number 1. All right, so the remainder theorem is a clever way of plugging numbers in without having to do a lot of crazy math, like exponents and stuff. Here's what the remainder theorem says. The remainder theorem says that if you divide a polynomial by, like if you use synthetic division, so if we were going to do synthetic division on this, you know, we'd have a number in the half box, which we don't know yet. Just hang on. There's our half box. And we're going to put this polynomial, the numbers, across the top here, just like in synthetic division. But remember, in synthetic division, we do not put the letters. We just put the coefficients. This is going to be a 2, x to the third, then x squared is 5. Now notice there is no x to the first term. So what are we going to put in? We're going to put in a 0, a placeholder 0, right? And then we got negative 7. And you might say, yeah, but you're not dividing by anything here. And I said, I know, I'm not using synthetic division to divide a polynomial. I'm using synthetic division to evaluate a polynomial, to plug a number in. Whatever number we would plug into this, if we put it here in the half box and then do synthetic division, whatever the remainder is, that would be the answer for plugging that number into the polynomial. Here's what I mean. Didn't we just plug 1 in here and we got 0 as an answer? Well, let's plug 1 in here and now let's do synthetic division. So we're going to put a 0 here, add. 2 plus 0 is 2. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. 7 plus 0 is 7. 7 times 1 is 7. And negative 7 plus 7 is 0. And that's not by accident. That's for real. If we plugged a 1 into this polynomial, the answer would be 0. So here's what I want to do. I want to use the remainder theorem. I want to use the remainder theorem to plug these numbers in to this polynomial. If we have this polynomial and we were to plug a 3 in, now you can do this, you can put this in a calculator if you want to and confirm this. If we were to plug a 3 in for x in this polynomial and then do the calculation in a calculator or even in our heads, what would the number be? What would the output be? Well, we can find out by using synthetic division. We'll put this 3 in a half box, then we'll put a 2, then a 5, then because there's no x to the first power, we're going to put a 0, and then this negative 7. And then we're going to draw a line, and we're going to do synthetic division. Put a 0 here, 2 plus 0 is 2, times 3 is 6. 6 plus 5 is 11. 11 times 3 is 33. 33 plus 0 is 33. 33 times 3 is 99, and 99 minus 7 is 92. So the remainder is 92, therefore f of 3 is 92. Now, I have a calculator here, and so what I can do is we can prove this. Let's go here. Let's do 2 times 3 to the third power times 3 to the third power plus 5 times 3 to the second power plus 5 times 3 to the second power minus 7. Minus 7, press enter. Sure enough, 92. Okay, so if I were to plug a 3 in here, the answer would be 92. And by using the synthetic division and the remainder theorem, we can identify this without having to do a lot of messy math. Now, you might have thought the 99 in here was a little messy, but it's not nearly as bad as raising big numbers to powers. Okay, so basically what synthetic division allows you to do is it allows you it becomes, what synthetic division becomes is it becomes a calculator for you for plugging things in. All right, now we have f of 9. What is f of 9? Well, I'm going to keep all that up there. I'm going to erase down here. I'm going to erase here because we're keeping the same polynomial. I'm going to erase what's in the half box. And I'm going to put a 9 in here. Now, do you want to try this? Do you want to go ahead and pause the video and see if you can put the 9 in, do the synthetic division, and find out what the remainder is? That would be your answer. Go ahead and pause. Okay, so now I'm going to do it. So if I put a 9 in the half box, and same 2, 5, 0, and negative 7. Remember, the 0 is here because there's no x to the first power term. Put a 0 here. 2 plus 0 is 2. 2 times 9 is 18. 18 plus 5 is 23. Now, we may need a calculator for this. What's 23 times 9? On here. 23 times 9 is 207. 207 plus 0 is 207. 207 times 9, it's 1,863. Minus 7 is 1,856. And so, if you were to plug a 9 in up here, you would get 1,856. All right? Let's do negative 2 now. Let's find out what f of negative 2 is. You're plugging negative 2 into this function, but instead of plugging it into the function, you're using synthetic division and looking at the remainder. Okay, so we'll erase here, erase here, erase here. Go ahead and try it on your own. All right, let's see how you did. So I'm putting this negative 2 in this box. Now, I want you to notice something. When we did synthetic division, we were reversing the sign, right? That's because it was a factor. It wasn't as a root, or it wasn't as a number being plugged in. If we had x plus 2, if we were dividing this by x plus 2, the opposite of plus 2 is negative 2. So we were changing the sign. But you are not doing that with the remainder theorem. You are plugging in exactly what you see. If we're plugging a negative 2 into the function, we're plugging a negative 2 into the synthetic division. Now let's try, we're going to put a 0 down here. 2 plus 0 is 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. 1 times negative 2 is negative 2. Plus 0 is negative 2. Negative 2 times negative 2 is 4. Plus negative 7 is negative 3. So the answer is negative 3. So say, if we were to plug a negative 2 in, the answer would be negative 3. Now let's try this f of 13. All right. Let's try f of 13. That's an easy theorem, right? I mean, you're just using synthetic division and looking at the remainder. That's all you're doing. All right. Why don't you go ahead and try it? Pause the video. All right, I'm going to go ahead and put the 13 in the half box here. Got my calculator ready in case I need it. So I'm going to put a 0 under here. 2 plus 0 is 2. 2 times 13 is 26. 26 plus 5 is 31. 31 times 13. 31 times 13. 403. 403 plus 0 is 403. And 403 times 13 is 5,239. 5,239. Subtract 7 from it, and we get 5,232. And so if you were to plug 13 in for x here, you would get 5,232. And that is the remainder theorem.